chemical reactions, so using chemical reactions to produce electricity for anode cathode. So reaction be familiarized, something that reaction cell like that. Positive terminal, cathode, negative terminal. So glass need to be non-metals. So the voltage here will per times electrons. Okay, it is very obvious. Okay, in future examination, there will be a mixture of electricity in our homes, industries, manufacturers, because it's there we write energy through their theories and concepts. We need to be factories, companies, schools, universities, institutions, park, beaches, and houses. Mr. Nernst to illustrate the Nernst equation. This is used to cathode and because it depends on their physical property, but most of them are not to electricity, whether it's slight, conductivity, strong, electricity, react, okay, electricity, which is the insulator, so it could be a rubber. What is the formula of Nernst? The first formula of Nernst equation, voltage. The voltage is another term, but when we speak about potential, voltage. Okay, voltage standard like this. Over the number of electrons, small percent. Okay. Okay. Guys, this is a standard cell standard minus R times. You can see the circle at the top is the if you will see a small, because some problems that's okay, that it's gonna be the standard, remember SRP, okay, or selling regular is equal to the E cell potential standard. Yes, okay, logarithm. The problem here in my left hand, and we can use this also later on. Okay, so that we can compare the values of concentration. We have E cell potential, the N per here, the smallest means the number of electrons, not the number of moles. It's not okay, something like perfect. Course or profession or curriculum as an engineer, so electrical engineer, discover something like this. Okay, and in fact, engineering mechanics also. Really, okay, so that it's very fast, even we can answer that. No, it's not like that, because it's not really 100%. Okay, because as you grow older, also 8 years old, we will become forgetful, and it's ours. No one is exemption to that. No one is exempted. Okay, like that. So we have to take care of our minerals, full of antioxidants and vegetables and rich in flavonoids. You can 3 times 10 to the 23, and then we can arrive to this value. Okay, then multiply to the Boltzmann constant. The Boltzmann constant also is derived from the universal gas constant 8.314 joules per mole Kelvin. That's why we have a Boltzmann constant, which is equal to like that. So, okay guys, if you're taking engineering that, medyo mo magkumpiyansa. Okay? More difficult is very more stats. Okay? Something like that. The basics really. Okay? I told you. Over and over again. Okay? Like that. Guys, the R is the oxidation. Okay? Like that. Okay guys? Okay, now, if we increase this one, R and anode, this problem, going back to the problem, I have now to elapsed. Okay, what is the cell potential of the reaction shown? Oh my gosh. Solid plus cuprous aqueous is equal to aluminum aqueous plus copper, chemical formula in each, right? So, and then we need to balance for this also. Okay, now we need to determine each element formula like that. Okay, so or chemical formula. So aluminum is Al. S means solid, as phase of matter, whether it is solid, liquid, gas, and that is very useful to understand well. Okay, so El as aluminum solid. Okay, plus what is cuprous aqueous? Cuprous aqueous. Cuprous aqueous meaning the copper that has been dissociated into the aqueous solution. So it became aqueous because it's already in the solution. When an element or metal is in the solution, it will dissociated or it's in the aqueous solution, it will produce solution, it will remain neutral, no charge as solid itself. Something like that. So still neutral. Okay? But if you will put that in a solution, in water aqueous solution, it will become positive 2, positive 1, negative 1, negative 2 like this. There's charges already. If you try to drop it or put that in the solution. So this is aqueous now, so it will become copper charge 2 plus. Okay? Aqueous. Don't forget to put the aqueous, the solid, the liquid, that's the phase. Okay? Something like that. Cuprous, meaning cuprous is just only copper, huh? Okay, because we have also copric. Copric is 3 plus and cuprous is 2 plus. This is only the the Greek terms of our scientists before. That OUS means the lower charge and IC means the higher charge. Another example for that is ferrous in iron. Ferrous also have positive 2 charge and we have also positive 3 charge. When it is now positive 3 charge, it is ferric. So just add IC. This is a rule in chemistry, general chemistry lecture. Okay, something like that. So I tell you cuprous because there are 2 copper exists in its charges. When you put that in a solution, okay, any kind of solution. Okay, so this is cuprous 2 plus 2. Unless specified, it should start with 2 plus. But if specified, then 3 plus will be there. Like this, it's not specified, right? So automatic 2 plus the cuprous. Okay, but if it's specified, then 3 bingo. We are very happy to that because it's already specified. No need to vary off. Oh my gosh, okay. So this is copper, Cu, positive 2. Okay, like that. Then aqueous. Okay, like this, aqueous. Okay, like that. Okay, every time you put aqueous, there's a charge at the top, ha? That's an identification. If there's no charge at the top, then state the phase, solid, liquid, and gas. But it never be an aqueous. Okay? Small technique only, okay? Something like that. And now we have the aluminum, solid, El, solid, metal. So has no charge, means neutral. And it is neutron in it. That's why neutral. Okay? Like that. Then aluminum. So this is aqueous, right? So aluminum aqueous. So very quick. So aluminum positive 3. Okay, then aqueous. Okay, very quick. The brain cells are very quick to detect slight mistake, something like that. Okay, plus copper solid, Cu US like this. Now guys, in here, if you try to balance this one, if we talk about the number of atoms, this is already balanced, and the number of moles. But if we talk about charges, these are not yet balanced. You know guys, redox equation are very special. We are not only balancing the number of atoms and the number of moles, but we are balancing also the charges. You get the point? Okay. Again, redox chemical reaction is not balancing only the number of atoms and the number of moles, but it's also balancing the charges. Could either be positive or negative charges. Okay, something like that. That's why we need to add electrons in your individual half reaction. Okay. In this manner, guys, the first step to do in order we have an overall chemical reaction, the first step to do, okay, is we need to determine which among the aluminum and copper has a very strong, so that we can distinguish which among them will gain electrons, okay, will accept electrons, increase the oxidation number or the oxidation number. That's the first step to do. Discover first if it is a weak pool of electrons and a strong pool of electrons. Now, I will give you technique. Okay, if we speak about the weak pool of electrons, the value of the voltages are very small. Again, if that is a very, okay, again, if it is a very, if it is a strong pool of electrons, be careful with this guys, because you know this is also very confusing sometimes. We need also to sometimes to condition our brains, okay, like that, because it could not be denied if so many things in our minds, then we will be thinking another way around. But just like this, we will just focusing on the live streaming. So if you will just do other thing, then you will be, you know, too much things in your mind, then it could be mixed up, something like that. Okay. You got the point? Okay. Discover first which is the weak pool of electrons and the strong pool of, what do you mean by pool in chemistry or in physics? Okay, we have force is either you're gonna push, you're gonna pull, like that. If you will pull, you involve force. That is an inward force. And if it is a push, then you have to push something that you involve outward push or outward force away from your body as your reference point, something like that. Okay, it's very clear, huh? So the behavior of elements and metals are also like that. Okay, they need to pull the electrons and they need to push the electrons. You have to accept, you have to pull, something like that. Okay, an element or a non-metal that will try to pull the electrons to them, so that is strong pull of electron, will undergo the process of reduction. Okay, remember the clue or the hint or a technique. Okay, if the element or non-metal will pull the electrons toward them, that means they have a strong pool of electrons. Okay, now if the element and metal will try to no longer need more of the electrons, then because they are more stable now with the electrons they have naturally, then they are weak pool of electrons, meaning to say they are going to share the electrons to the other, which is having a strong pool of electrons. You get the point? Now, the weak pool of electrons is undergoing the process of oxidation, or the anode will be there, the anode cell. Okay, and in the reduction, the cathode cell will be there. Okay, the negative terminal. like a battery, okay? And then the passive terminal is in the anode, something like that. And you should not mix up this principle because somewhere along the way, it can really confuse sometimes, okay? Something like that. Now, I will introduce you some clues for this also. When we mean of a weak pool of electrons, meaning you don't need much electrons by themselves, right? So these are oxidation, and then anode. So this is an ox, meaning anode oxidation. Now, if this is a strong pool of electrons, this is a red cup. Just like our cup that is red. Red cup. You see a red cup, then bingo, that is a reduction. Meaning to say reduction cathode. Just to remember faster. Red cup and ox. In dealing with redox. So you must familiarize this. Okay? Like, or you can have also the rega and the low ox. If I say rega, meaning there's a gain of electrons, then reduction. Re stands for reduction, ga stands for gain of electrons. And then if I will say low ox, dili low ox ha? Low ox. Low ox meaning loss of electrons and the process is oxidation. So that we can easily remember, distinguish and identify, and it makes us easy during memorization. Okay, if we don't have abbreviation, shortcut way of memorization, then it will have a tendency to retain in our brain cells for a longer period of time. Something like that. Okay. Now guys, this is not it balanced. Now, second procedure, we need to determine the weak pole of electrons and then a strong pole of. The second procedure is we need to determine, I will put the procedure so that this will be the technique. Okay, bisag tutuwaron pa na siya sa problem, we can really solve na talaga siya if we have the method how to solve it. Okay, number one, determine, oh my gosh, determine, it's very cold already, oh my gosh. Now the first technique in solving this type of problem in electrochemistry and electrolysis is to determine if it is a weak pool of electrons and a strong pool of electrons, as what I discussed a while ago. Okay, so WPE meaning weak pool of electrons. So determine WPE, and SPE meaning strong pool of electrons. Okay, determine WPE and SPE. Ganon. Okay, so since I told you already that the WPE is in the oxidation anode and the SPE, something like that, is in the cathode or the reduction. The second step, guys, is we need to determine the SRP, the South Reclamation Project in Cebu City, or the selling regulatory price of certain product regulated by Department Trade of Industry, DTI. No, it's not like that. Sorry, that's only a joke. But SRE means standard reduction potential of all elements, could either be metals or non-metals, at 25 degrees Celsius at standard temperature. Okay, most of the problems will never stick at 25 degrees Celsius already. It is already understood that it is undergoing the 25 degrees Celsius, especially when the values are given in the problem. No need to, to investigate, oh, what is the temperature for this? It's automatic if it stated the correct voltage for that particular element. Okay, because that is a 25 degrees standard already, especially if the latter have a small circle at the top that is a standard value, that's like just like the gives free energy. There's a small circle at the top of the capital G, just like that. And here also have the small letter, the small circle at the top of the E cell. E cell, guys, is capital E cell, meaning C-E-L-L, the spelling is like that, C-E-L-L, capital E, C-E-L-L, with a small circle at the top. That is electron to push and to move and to flow in a path or in a wire to produce electricity and electrical energy. That's why electrochemical cell. And the cell is composed of a reduction cell or the anode cell, or the cathode cell, anode cell, reduction cell, oxygen cell. Cell, C-E-L-L. Okay, ganun siya. In this perspective only, because the another definition of cell also in biochemistry is another thing. Cells are our body is composed of so many cells in our organs. There's another term also, CELL. Okay, so mean to say that is okay, this is her meaning, right? Like that. Cell, different meaning according to their application and usage. Okay, a lot of example for that, right? Okay, and I don't have to do that because this is an English vocabulary or whatever, or grammar. You know what I mean. Antonymy, homonym, and synonym. Okay, in English grammar. Okay, something like that. And we don't do it here. Okay, so that's number 2. We need to obtain. Obtain and determine is just the same in concept, huh? Again, synonymous terms. Okay, determine, because if we obtain, did we determine? Because this is a close relationship with each other, with action verb. Okay, meaning we determine, we need to act. Okay, through our hands, our eyes, our brain cells. So anything that involves action, that is verb. So determine. Okay, determine the SRP. I just to make it shortcut. SRP meaning standard reduction potential. Oh, ganon. Now, what is the number 3 step? The number 3 step, guys, is you have to illustrate or represent the half chemical reaction in the anode and in the cathode. Meaning, illustrate, okay, illustrate each, okay, half cell reaction. Okay, meaning of half cell reaction individually, the anode oxidation reaction and the cathode reduction, like that. Okay, illustrate each half cell reaction. Ganon. Okay, so 2, you will produce 2, right? The reduction and oxidation. So I will say reactions, plural. Illustrate each half cell reactions. Okay, like this. Could either be oxidation and, my gosh, reduction. Now, guys, number 4 method, it's here, okay? Number 4 method is we need to have the electrons by specifying each. Okay, for example, oxidation, and then reduction, then there's each chemical formula. Then we have to add the 2 half cell reaction after balancing the number of moles and electrons. Okay, add the 2 half cell reactions. Okay, my gosh, half cell reactions. Okay, after balancing the number of atoms, okay, balancing the number of atoms and the number of electrons. Okay, guys? Okay, ganun siya. Okay, and electrons. Okay, and after adding that one, guys, it's always like this. We need to cancel out the total number of electrons in each reduction in each anode so that it will not appear in our overall electrochemical reaction. Okay, we need to cancel that out because those electrons are being neutralized with each other already. Especially the other electrons are in the reactant and the other also in the product. So by algebra principle, left and right will be cancelled out if they have the same quantity. Okay, so electron, same quantity, right? It will be cancelled automatically if the same, okay, including the number or the figure For example, if the number of electrons in the left side or in the reactant is 2 electrons and the product is also 2 electrons, then bingo, we can cancel that out so that our overall electrochemical reaction will not involve now the number of electrons. We do that because in our Nernst equation, here, the two equations I presented a while ago have a number of electrons a small letter n. So we cannot solve that if we will not be able to determine the number of electrons produced in each half cell reaction. There's a purpose for reaction. We need to cancel those electrons. So that in our electrical, got the point? Any objections so far in my discussion? Something like that. Okay. Guys, Q, capital Q is not the heat energy here in electrochemistry, but chuba chu chu. Okay, Q is equals to NCP dt chuba chu chu. Q is equals to NCV dt chuba chu chu. CV meaning a constant volume, CP a constant pressure, and then it depends if the system also is a closed system, adiabatic, or isothermal, isovolumetric, okay, isochoric, or whatever chuba chu chu is being held constant on that particular formula. So you should be clever and smart enough to determine that. Again, the basics. Okay, something like that. Okay, so in here, the capital Q, again, it is not the heat energy. The Q here is the reaction quotient. Q is equals to the concentration of the product. Okay, guys, in chemistry, general chemistry lecture, be a molarity, molality, or normality, something like that. Okay, so the close and open parenthesis is very helpful to you guys. Okay, over the reactant close and open parenthesis, something like that. Now, in here in electrochemistry, our product is always our product is always the product is always our cathode. Okay, the product is always our cathode. Okay, so I will put cathode, close and open parenthesis, over anode, close and open parenthesis. Okay, guys, since you know what redox is in the anode, then bingo, you can substitute there the concentration, and the anode also what's in there, then concentration, then bingo, you can solve for that. Okay, so that's our Q, and it's easy to logarithm for that. Okay, logarithm of Q, of course, if you have values for P and R, you have the value of logarithm and ln for Q. Okay, something like that. Okay, you get a point? Okay, something like that. Okay. Okay, so it's very clear. And now, go back to the problem. So this gas is not yet balanced, ha? Okay, the equation I presented. So now, we have the 4 methods how to solve now. Then apply now in our solution. Okay. Determine the WPE, so determine the SRP. Now, today I don't have the books in chemistry, physics, or thermodynamics book, or physical chemistry book, or any unit operations book, or like Paris Chemical Engineer's Handbook. I don't have now. So I have to Google search in the mobile phone. No other choice. Okay, so I have to Google that one. So SRP, okay, it's here, of course, in the online world. Okay, something like that. So, Google search. We cannot memorize this because this is very complicated. The table is very complicated. We cannot memorize. Okay, if you want to, then you can go. Yes. Okay, something like that. Encoding standard. Reduction potential. Just type in your mobile appear there, here. So click. So I have so many here, right? And the table is stacking process, meaning the gain of electrons. And if you try to determine that, it's always SRP, or standard reduction potential. It can never be an oxidation. Okay, that's my point. Mamatay na lang tag pinangita, wag yun siya oxidation potential table. It's always SRP, standard reduction potential. That's why the anode or the oxidation, the one will be keep on adjusting in our chemical reaction, in determining the overall chemical reaction, or in determining the overall electrochemical reaction. Now, we have aluminum. Okay, aluminum solid here. Oh my gosh, we don't have paper, a blank sheet of paper. Ganon. SRT of aluminum, meaning to say reduction process, right? So, kung sa ganito, okay, aluminum, 3 positive aqueous, goodness, plus 3 electrons, okay, is equals to aluminum solid, okay. So this is our reduction equation for aluminum. Always remember guys, electrons. And bingo, you can understand already. It's always plus electrons, plus electrons, plus electrons. If you're talking about reduction, ha? It's not the reverse. Okay? Like that. So, gain of the rega. Okay, now, the value of the potential is negative 0.66, negative in fairness, voltage or volt, V-O-L-T, the unit of voltage in Ohm's law. Okay, something like that. Now, I need to determine also the SRT of copper. It's in here. Oh my god. Copper. Oh my gosh, it's in here also. So, okay, yes, again, because this is a reduction in the SRT, okay, plus 2 electrons is equal to copper solid. Okay, like this. Pareho rin siya guys, both of them are SRT man siya, reduction. Okay, so it is copperus. In fairness, positive 0.34 volts. Okay. Now, unsa ganito kung giingon first step, determine the weak pool of electrons and the strong pool of electrons. In here, a strong pool of electrons and a weak pool of electrons by considering the value between negative and positive. Again, theory. Okay. If it has a negative sign, sorry, not charge, sign of a volt, meaning to say, guys, this needs more electrons to do with a charge thing. Okay? Because we know the electrons is negative, right? And the negative of the volt here is nothing to do. There's no connective sign. Okay, if it needs more electrons, guys, meaning to say, okay, cathode. Sa ganito kong gingon, red cut. Oh, reduction na yun. Oh. Because I told you for the technique, aluminum solid. Okay. Identify first. This is the number 2, determine the SRT. Okay. And the 0.34 volts is positive, right? So this is the weak pool of electrons because this is more stable already. Okay. And of course in the anode, meaning anox. Okay, anox meaning anode oxidation. Okay, meron siya, di ba? Okay. Follow me step by step so that we can understand. Okay, so it's gonna be copper solid. Okay, like this. Okay, now it's easy now to compute for the overall chemical reaction. Okay, in rule in electrochemical reaction, guys, we don't need to add the same reduction. If the other one is treated as a reduction, the other will be automatic as an oxidation. You get the point? Okay, like that. Now, there are two methods in determining the E potential. The E potential of the two aluminum and copper. There are two techniques. The first technique is to use the theory, which is E cell at standard value is equal to the electric high potential, which is the electric high potential in the cathode, right? Minus the small electric potential or lower electric potential. Or it could either be stated also as the E cell standard potential is equal to the E cathode minus the E ways how to do that. Okay? And then in this case, we need to change something in order to be compatible with each other. So which among them we need to change? Okay? But before that, I want to emphasize class that, if we have a negative 1.66, okay, it needs more electrons, right? And a positive, of course, it will give off. Then why electrons, guys? Because, this is positive, right? Okay, if this is a positive 0.34, okay, why it contains more electrons? Since we know this is positive, okay? Supposedly it contains more proton rather than electrons. So there's something also confusion a little bit, huh? Okay, again, copper solid has a charge of 2, right? So 2 is a proton, right? At the top, or a valence in the outermost shell, if you can remember the chemistry, right? But why this copper will produce more electrons so that it can be shared to aluminum? That in this first place, he has so many charge, which is 2 positive, and this we refer to electrons, not the protons. Sometimes there's there's a little bit confusion. Okay, you understand the point? So I have positive 0.34 volts of this copper. So meaning to say pala guys, this is not related to the charges already. This is related to the volt. Okay, or the potential. So never consider the charge in telling weak pole of electrons or strong pole of electrons. You get the point? Because you will be confused if you use the basis of the charge. For example, copper, the charge is positive, right? And then why it will give off more electrons? That is a positive charge. Supposedly he needs more electrons because it is positive. You get the point? Unless it is an oxygen gas. Oxygen gas is a negative electron, right? Okay, then in this concept, supposedly the oxygen will give electrons, right? Because it is negative. But in here, it's not. It still depends how weak or strong among them to pull electrons over the other. You get the point? It's not really the charge that matters here. It's the voltage or the potential that we can say weak pull of electrons, strong pull of electrons, because there's a contradictory also, okay? Like aluminum. See, aluminum has 3 positive. There's a lot of proton, right? And then that's negative 1.66. I mean, he needs more electrons, right? Why? Okay, so we will never go into details because it's already proven theories and concepts. So we will not argue for that. Let's agree for that. Okay, now it's in the voltage thing, huh? It's not on the charge. Okay, something like that. Okay, now how can we do this to determine the overall chemical reaction? Okay, guys, here in this reaction, what is the cell potential of the reaction shown aluminum? This is, for example, I am in the laboratory. I'll just get the aluminum solid and the copper. Try to react that in the aqueous solution. Guys, I don't use any devices for that. Okay, remember the theory? If I don't use any devices, just like a battery or any appliances or any equipment in the laboratory, this is now natural process. If you're just mixing, for example, I mix the sugar and the table salt in the kitchen, that is natural. You don't put any energy to mix that all the time like that. So that is a natural process. So that is spontaneous chemical reaction. We don't heat that. Okay, we don't stir that. We don't touch anything. You just put them there and let them mix with each other. So that is spontaneous chemical reaction. Okay, the chemical reaction, guys, will proceed by its own without touching, without adding any energies on it, without moving it, without heating it, without mixing it. You just put that there, then bingo. So that is a spontaneous chemical reaction. Now, by theory, what is a spontaneous chemical reaction in terms of potential? Okay, in terms of potential class, the volt is always positive if you have a spontaneous chemical reaction. Now, in here, we have a negative, 1.66. So what can we do in order to have an acyl negative also? Then, we need to change the sign of the aluminum to be positive, to be subtracted to 0.34, something like that, okay? You understand the point? We need to change the sign so that we can have a value of positive. Because if we have a value of E potential, that is already not spontaneous. But in here, guys, in our problem, we don't add anything. This is a natural reaction. So, we let our E potential to be always positive. And how can we do that? By adjusting, could either be the oxidation and the reduction, because this is a spontaneous chemical reaction or reversible chemical reaction type. The electrolysis is the reversal. This is not yet electrolysis. This is electrochemistry. The electrolysis using battery, galvanic cell, voltaic cell to produce a chemical reaction that could derive electrical energy. This is another thing. Just like the water. The water, you need to put that in a vessel. There's a battery. You need to connect that in the two electrodes. This is not like that. We don't put here, a device or anything. Okay? So this is spontaneous. The chemical reaction will proceed by its own to produce an electrical energy when electrons flow without adding any equipment, tools, without any physical operation, chemical operation or anything. You just put that there and bingo, kalas, like that. Okay? You put that there, then let them react. Okay, is that what we mean by spontaneous? Okay? And we don't even add catalyst for that. We don't increase the pressure. Okay, we don't increase the volume, the operating condition. We don't increase the density or whatever, chupa-chuchu. We don't change the pressure, blah, 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 so and so, like that, okay? You get the point? Oh, ganun siya. Zero. Nothing. Okay? So this is spontaneous chemical reaction. Just like thermodynamics, right? Okay? So what is the cell potential? Ganun siya. Now, what's a lot way, in fairness? Gravity, if we did explain this in detail too much, okay, something like that. Okay, now, how can we do this? Okay, now, so we need to change the negative 1.66, which is an aluminum. So in here, the aluminum is the reduction. Okay, the aluminum is the reduction. And in here also, the aluminum is here, right? Okay, this. Now, since we know that an aluminum is an SPE, now our Q here will be Q, reaction quotient, equals to the product. By definition, product over the reactants, so it's going to be cathode over the anode. And our cathode here, guys, is the aluminum. Okay, then since we know the cathode is an aluminum, then we need to make it a reduction process for the aluminum. Okay, so this is already correct. Something like we treat this cathode as our weak pool of electrons. Okay, something like that. You get the point? Again. So our weak pool of electrons is here. Okay, so that we can understand further. This anode and oxidation. Okay, that's the weak pool of electrons. Our anode here is the, okay, anode here is the, very clear, copper siya. Copper. So we put the copper on the anode, downside. Right? Okay, mo siya anode. Ganon. Okay, now our cathode, guys, is aluminum, right? So put the aluminum at the top side. Aluminum solid also. Okay, like that. It's gonna be like that, right? Aluminum solid over the copper solid. Oh, ganun siya, choba-chocho. Now, in our problem here, okay, the concentration of the aluminum is how much? Okay, the aluminum concentration is, it's stated there, aluminum 3 positive, chararat. Okay. Okay, so 2.5 molar, something like that. Okay, 2.5 molar. Okay. And then the concentration of cuprous 2 plus, ganun. So we need to have the molar concentration so that we can substitute that in the Q. Okay, ganun siya. Now, since we are having the cathode aluminum, okay, because it is a strong pull of electrons, aluminum. So the aluminum is as is here, as is. We don't have to change. So we have to state again, aluminum, because so aluminum, as a rule, we need to reverse one of them so that it will be compatible with the reaction with each other, or else the number of electrons will never be cancelled. Okay, something like that. That's the purpose there. Okay, and if it is not in reverse also, how can they gain electrons with each other? Okay, this should be opposite with each other. So that's, that's very logical, right? So 3 electrons is equals to aluminum salt. So this is our equation 1 now for our cathode, right? O ganon. So the other one, guys, will be our anode. So wala na tayo choice. Ang anode na to is copper. Okay, since our reduction potential is here, so we will reverse this reduction potential. So it's gonna be copper solid, okay, is equal to cuprous 2 positive, nakakaloka, chaos plus 2 electrons, our equation 2. Ganun siya. And this is now our half cell reaction. Oh my goodness. Okay, as you can notice in our half cell reaction, guys, the electrons are not balanced, but the number of atoms of aluminum and copper are balanced. Check. So we need to balance the electrons. How can we do this? Again, by applying the principle of algebra, if we try to multiply each by a certain factor so that they can be equalized with each other to cancel them out. So it's gonna be, we will multiply the cathode by 2, and we will multiply by 3 the coppers so that we can eliminate that in our overall chemical reaction, in which we are now on the number 4 step, add the 2 half reaction and balancing of atoms and electrons. You're following our solution, right? How to solve? Okay, now, so times 2, the first equation, times 3, the second equation. No, it will become now as this one, guys. Okay, the whole thing, if you multiply that one, the whole thing, because it is overall, the whole thing of an oxidation, and the whole thing also of the reduction, multiplied by a certain factor, so that we can neutralize and equalize, and you can balance automatically the number of electrons, so that we can cancel out, so that we can have an overall electrochemical reaction. It's gonna be like that. Okay, this is the step, Okay, now, okay, so we have 2 aluminum aqueous. Guys, never forget the labeling, in the subscript, aqueous, solid, liquid. This is very important in electrochemistry redox chemical reaction. Okay, never forget that one. Okay, so this will always come up in the board examination. Sure. Okay, so 3 positive plus, okay, 6 electrons, because it will multiply by 2, is equals to 2 aluminum solid. Okay, now this is the equation 1, because we are multiplying by 2 factor. Now in the second equation, guys, we have to multiply by 3. Okay, now it will become now as 3 copper solid. You'll never say cuprous as copper, because this is the element, or the metal itself exists as solid, not a charge in aqueous solution. You get the point? So that is 3 copper solid, okay, is equal to this one, cuprous. Cuprous 2 plus, or copper 2 plus, okay, aqueous. Ganon. Talaga may labiling talaga, no? Okay, ganon siya. Okay, 3. Oh my gosh. Okay, plus time plus 6 electrons, because they multiply man to 3. Okay, 6 electrons. As you can notice, if we add the 2 half cell reaction, we can cancel out the number of electrons. But before that, we need to determine our small letter n is equals to 6 electrons, because this will be used in our Nernst equation. 6 electrons. Small letter E with underline at the top of the small letter E, this would mean electrons. Okay, because this is not positive. So we put negative at the top of the small letter E. Okay, small letter N is equals to 6 electrons underlined at the top of the small letter E. So this is our N. Okay, now, so this will cancel now. Oh, ganon. So 2 aluminum, 3 plus aqueous, group the reactants and group also the products. Okay, group according to their nature, or according to their compartment, according to the group. Okay, not mixing. Okay, that's the rule also. So plus 3 copper solid is equal to 2 aluminum solid. Okay, like that, plus 3 copper 2 plus aqueous. My goodness. Now, again, if we multiply the factor 2 in equation 1 and 3 in equation, look, balance again the chemical reaction because we have a factor already. It is balanced already or not? Okay, let's check visually, individually. Okay, aluminum to the right and aluminum to also the right. Okay, 3 copper at the left and 3 coppers also in the product. Copper is also positive too because we already cancelled in the chemical reaction. So this is the balanced chemical reaction now. Okay, guys. 2 aluminum 3 plus aqueous, okay, plus copper solid is equal to, what's this? I cannot see. 2 aluminum solid plus 3 copper to aqueous. Okay, like that is the complete overall chemical reaction. Now, if the examination will state, what is the overall chemical reaction? This will be your answer. Okay? Gets? Okay. Now, we need to solve what is the cell potential of the reaction. The cell potential is being asked, not the overall chemical reaction. But we cannot get the cell potential if we will never determine the overall electrochemical reaction. That's only our purpose. Okay, for that. Now, cell potential here, we can use the Nernst equation in my introductory discussion because, guys, there's a molar concentration. Okay, if we add is equals to a cathode minus E anode, it's not. There's a molar concentrations involved. So we cannot apply that one. So we need to apply the Nernst equation. Okay, and sa ganitong molar concentrations of aluminum, given siya, so aluminum, okay, 3 plus is equal to, ganun siya, 0.1 molar. Capital ang molar, guys, ha? Capital N. Muna siya. Okay, and our coprus 2 plus is equal to 2.5 molar. Ganun siya. Nakakaloka. Okay, and our E cell at standard condition, we have 2 volts. Okay, like that. Like that, 2 volts. Now, our equation here in my introduction, oh no, my goodness, nakakaloka na to. Okay, it's here, right? In substitute values na ka. You can choose either equation 1 and equation 2 of Nernst equation because it will yield the same answer. You can use the logarithm part and ln part. You can have a choice which is more comfortable to you. It will yield the same answer talaga siya. Now, E cell, okay, like this. E cell is equals to E standard cell, kaloka, okay, is equal minus, we'll choose the equation 1 lang, RT and F, ln Q. Okay, ganun siya, chuba-chuchu. Okay, RT and F, ganun siya, ln Q. Okay, ganun siya. Now, guys, our Q, guys, will based on the equation and the overall chemical reaction here, not on the unbalanced chemical reaction that the problem is stated in the originally. Okay, so Q is equal to, since we have here the cathode over anode, and our cathode is, sa ganito itong cathode. Okay, our cathode is the asabi ito atong original na papel. Tawag tang siya. Kung man ako gi-memorize, we are here. The cathode is, okay, the cathode is aluminum. Okay, so Q is equals to the cathode, aluminum. Ang aluminum na to is, it's here given the concentrations. Okay. Saan naman to, oy? Okay. Aluminum is 0.1 molar. Okay. And over 2.5 molar. Muna siya. Cathode over anode. But this is not yet considering the charges in the chemical reaction. Our chemical reaction for this cathode aluminum in our chemical reaction here, the balance Here, aluminum. Okay, we use the 2 moles of aluminum 3 plus in the numerator. Because in here guys, we need to use the aqueous na siya solution because it's in the aqueous solution that the molarity will be obtained. Okay, if it is still a solid, the concentration is not yet 0.1. Okay, but if it is now in a aqueous solution, that is having now a 0.1. So that's why we use the aluminum 3 positive, not the aluminum solid. Understand the point? So it's gonna be 2 moles of aluminum, okay, 3 plus, which is 0.1, and like that. Okay. Now, over the, as ganito itong anode, anode and the other is copper. Copper na siya. So, the copper here, isa man itong copper here, guys. Okay. The copper will be 3, okay, like this, aluminum, okay, this product. Ganun siya, okay? Ganun siya, guys. Okay. Okay, 2, 3, sorry, this is 3 coprous talaga, no? Copper na to is ano man, 2.5. Okay, molar. Okay, guys. Okay, in this part, guys, it is very confusing, right? Some students, including me, will multiply immediately the 3, 2.1. But remember, this is the rule in equilibrium constant, because this is also reaction quotient in general chemistry lecture. What do we understand by chemical equilibrium constant? And also in the KSP, you know, so limited product constant subject or topic in chemistry. That is product of a reactant. But if there is a number of moles, beside them, the number of moles will be raised to the exponent. Be careful. So this is not 0.1 times, so instead, 0.1 raised to the power 2. Okay, because of the chemical equilibrium constant principle. So this is 0.1 raised to the power 2 and 3, 2.5 raised to the power 3. The coefficient will be the exponent in each reactant and product, or in each numerator and the product. Okay? Okay, it's different in chemical reaction kinetics, because in chemical reaction kinetics, the coefficient is not the exponent. It is the reaction order. So, see, there's a reverse. You should also determine that one. So, when you solve, you should troubleshoot what is the applicability of the problem. If it is a reaction kinetics problem or electrochemistry problem in physical chemistry. This is under physical chemistry, the electrochemistry. Okay, something like that. Now, we need to solve for the values for this. 0.1 raised to the power 2 and 2.5 raised to the power 3 bilang may answer niya, Ani. Okay, now we will obtain the value by using the calculator. Charot. Ganon. Yes. So, 0.1 times 0.1 is equal to blah, blah, blah. 2.5 times 2.5 blah, blah, blah. Okay, raised to the power 3. So our answer here is 6.4 times 10 to the negative 4. Wow, exponent. 6.4 times 10 to the negative 4. Okay, this is our Q. But take note, guys, this is to be taken as Ln pa, because it is NQ. Okay, like that. Okay, what is our equation? Substitute again here. So this is gonna be now this one. Okay, here. We use equation number 1, right? E cell is equals to the E standard cell, which is 2 voltage, is here. Okay, we write that here, right? Okay, substitute. Plain substitution na lang yun siya. So, 2 voltage or 2 volt. Okay, minus universal gas constant 8.3145 joules per mole Kelvin times 298 Kelvin. Okay, like this. Now, N. Our N is 6 electrons. Na ato siyang special. Okay, ato naman siyang determine. We determined this a while ago. 6 electrons. Okay, chararat. Okay, 6 electrons. Chivas. Okay, ganon. So, Faraday constant, capital F. Ako na siyang introduce a while ago in my introductory part. Is equals to 96,485 coulomb per mole electron. Ganon. Okay, guys. Ganun. Column, mole, electron. Okay. And then the ln of 6.4 times 10 to the negative 4. Ganon. Okay. Guys, di naman masulod, so that's gonna be like this. Okay. Okay, now we will perform the basic mathematics. Oh my gosh. Now in here, guys, we need to cancel what are the same quantity or units, huh? Okay, so in here, joules will be, no, mole will be cancelled. Yes. Mole. Kelvin will be cancelled. Okay. Electrons will be cancelled also because it's in the denominator of the Faraday constant. Okay, like that. And what's being left, guys? Take note, what is being left is a joules per column. Hala. Is joules per column is a unit of voltage? This is a question. My question is this. Is a joule per column is a unit of the voltage? Or it is equivalent to volt? Or not? Since we are here E cell as a volt, then if the E cell is a volt, then how can we subtract directly if it is not also equal to volt? Common sense. So, joules per column is also a volt. Tanawa ko ng formula. Our E cell standard is already volt, 2 volts. Then it is subtracted by this, part, okay, which is chuba-chucho. We still identify it. What's the value, right? Joules per column. So it is expected that is a volt also. Then I must explain that through derivation. Okay? So, okay. In practical electricity board examination, this is very, very common in practical electricity. Okay? Especially electrochemistry. Okay? The combination of chemical reactions to produce electricity or electrical energy is electrochemistry. It's being discussed partially in general chemistry lecture, but is discussed in detail in physical chemistry. Okay, something like that in higher science subjects. Okay, now we need to memorize this, please. Okay, voltage is equals to current times resistance. This is the Ohm's law. Okay. Now we have also the Coulomb's law. Coulomb's, Mr. Coulomb discovered Mr. Coulomb. Okay, the Coulomb's law is this: current is equals to the charge Q, represented by small letter q, or it's up to you, it would be a big Q, but the big Q mulubog siya sa thermodynamics. Because thermodynamics, we treat that as a heat energy, a capital Q, which is small letter q. Okay, small letter q, for convenience. Or for, okay. Now, I is also electricity topic discovered by Mr. Ohms. Also, electricity topic discovered by Mr. Ohms. Okay, now, Mr. Faraday is developing also another formula in which the Avogadro number times the electric charge, and that is discovered by Mr. Michael Faraday. So there are now 3 scientists that you know. Okay, Michael Faraday, Mr. Faraday, Mr. Coulomb, and Mr. Ohms. Right? Remember that one. It's very basic. Okay. So Mr. Faraday discovered this F that we use in the Nernst equation, which is 96,485 coulomb per mole electron. And do not forget this one also. Now, Mr. Coulomb discovered the electric charge value, which is 1.602 times 10 to the negative 19 coulomb. This is constant or value that Mr. Coulomb discovered. Okay, something like that. But Mr. Ohms has equation and the concepts behind voltage, resistance, conductance, resistivity, specific conductivity, the current, the ampere, like that, blah, 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 chuba, chu, chu. Okay, now, okay, I is ampere, right? Oh, ampere, we need to put ampere is equal to the charge. The unit of charge is coulomb. We need to put unit individually. Okay, coulomb, capital C, over time is equals to second. Now, bingo. We can say 1 ampere is equal also to 1 coulomb per second. Okay, now we can say also 1 ampere second is equal to 1 coulomb. Why? Because this is also in this equation. If we try to To solve for the value of the charge in your equation in algebra, Q is equals also to T times ampere, right? So ampere second. So 1 ampere second is equal to 1 coulomb. So memorize. 1 ampere second is equals to 1 coulomb. And what left now is here. You need to justify the joules over coulomb is the unit of the voltage. Okay, why? Okay, why? Because we have the formula of power is equals to the charge over the voltage. Okay, power. So I told you, memorize the basic, right? Power is equals to charge over the voltage. Guys, this power we mean is the electrical energy. Because power involves energy. You cannot do certain energy without power, just like doing our job. Okay? We cannot do without power because power would mean energy. The energy we apply to a certain object in order that object to move. Or in order we can move, then we have power. Not limited only to electrical energy, but limited to energy in terms of calories that we intake through the food we eat every day. Because there's a lot of energies. I told you consistently, there's a lot. Chemical energy, electrical energy, light energy, electrical geothermal energy, a lot of energies around us, not limited to electrical energy, mechanical energy, and chemical energy. But in here specifically, since we are dealing with electrochemistry, that would mean electrical energy plus chemical energy, because chemical reactions are referring to chemical energy. Without chemical energy, there will be no chemical reactions at all. If there's no electrical energy, then there will be no electricity at all. Malong, that's why electrochemistry. That's why we have light in our home, in schools, in factories. That's why our mobile phones are operating, our gadgets are operating, our laptops are operating, because there's an electrochemistry behind that. Okay, it's not only electrical energy. Electrical energy will not be produced without chemical reaction. Remember, the battery is composed of metals inside our mobile phones. Remember that. Okay, you get the point? That's gonna be okay. Justify the unit joules per coulomb is equals to volt. Okay, now, ganon. So since joules over coulomb. Now, we need to solve for the voltage. Hala. Okay, because we are trying to solve for the voltage because we need to know if it is really joules per coulomb. So, in this equation in algebra, solve for the voltage. Voltage is equals to power over Q. Okay, voltage is equals to power over Q. Since the joules is a unit of a power, it's an energy, so that is joules. Okay? And the Q is coulomb because it is the charge. The charge, the unit is coulomb through the discovery of measure coulomb. So this is G over C. So therefore, we conclude 1 volt is equal to 1 joules per coulomb. Therefore, technically and scientifically, 1 joules per coulomb is just equal to 1 volt. Due to Coulomb's theory and principle discovered by Mr. 1 joules per coulomb. So we will now memorize this so that in the future examination that involves electrochemistry problems, we can solve properly and correctly. Okay, we will memorize it again. Okay, 1 coulomb. Nakakaloka. 1 coulomb is equals to 1 ampere second. 1 ampere is equals to 1 coulomb per second. And 1 volt equals to 1 joules per coulomb. Or if you try to fail your memory, okay, you forget, then derive. No choice. Okay, like that. But for me, I memorized really this in college, in my first year college. Because this is not introduced in high school and in elementary level. Okay, like this. So this is gonna be 1 coulomb, 1 per second, 1 volt, 1 joule per coulomb, something like that. And 1 ampere is equal to 1 coulomb over second. So it's in this unit also we can solve problems, even though we forgot the formula. By units alone, we can solve the problems already. Okay, you get the point? If the problem is dealing with these units, then we can solve immediately through its units. Okay, and this is related to stoichiometric problem solving. And the other one solving is related to the conversion easily confuses me. Okay? Really, the value of this, how many this, cancel, don't like that one. I really want the appropriate formula. That's why in my part, also when I was in college, I memorized really being on the units, conversion factors. But I memorized some conversion factors, but I'm telling you only, I am preferring this type of solution. Like this cancellation E. That's why I would rather go to the memorization of the basic formulas to be used in my solution. Okay, it's gonna be like that. Oh my goodness. Okay, now let's go back to the original equation of the Nernst equation. Okay, in this. Okay, why? And we will law of thermodynamics, right? Remember that one? And the third absolute zero is equal to zero, the entropy. Okay, and there's a relation with Gibbs-free energy, but I need to research why. That's what I understand. That's why this formula is coming from him, because this also involves the Gibbs-free energy relationship. You know the point? Gibbs-free, especially if you are referring to electrolysis already. Okay. Electrolysis involves energy, as I told you, because it's not spontaneous chemical reaction. It's non-spontaneous, irreversible. We need battery, galvanic cell, voltaic cell to produce electrical energy. In here is natural kasi. Okay, so that's why these nerves are, related. That's why we have Nernst equations. Ganon. Okay, perform calculation please. Charot. Okay, ganun-ganun chuba-chucho. Okay, so ln of 6.4 times 10 to the negative 3. Okay, this is the value here. And then 8.3145 times 298, okay, divided by 6 times 96485, memory in, memory recall, so 2 minus memory recall, right? So our E cell is 2.013, something like that. Ganun siya. Okay, 2. So we need to determine the difference. Okay, 2.013 minus 2 is equal to 2.013 times 100 is equal to, okay, 2.0, okay, minus 2 is equal to 2.0 is equal to, okay, times 100 is equal to this. Okay, 2.03. Okay, I recheck it again because sometimes when you press the calculator too fast, it will become error. Okay, you notice that also sometimes. So that's why you need to double check when you press the error back. When you press